This video offers an introduction to the two most common types of 3D printer, how they work, and how their output differs in terms of size, strength, and detail. The one on the left uses FDM technology. FDM is an abbreviation for Fused Deposition Modeling, whereas the one on the right uses SLA technology. SLA is an abbreviation for Stereolithography Apparatus. Let's have a closer look at the difference between FDM and SLA. A simple way of visualizing how the FDM printer works is to imagine it like a glue gun. If we were to first draw a shape with a glue gun, let it cool, then draw another layer on top of it, then the basic shape would eventually build up into a three-dimensional form. However, instead of using glue sticks, this FDM printer uses thermoplastic filament as its printing medium. The printer heats the filament and is then able to extrude it in the same way as the glue gun. Many types of FDM 3D printers exist, and the more exotic ones have been designed and built to extrude everything from chocolate to concrete, from metal to mashed potato. The list is endless. The SLA printer, on the other hand, uses a very different technology. It incorporates a tank, sometimes called a vat, with a transparent base. Beneath the tank is a high-resolution screen that displays a series of ultraviolet images. The tank is filled with light-sensitive liquid, or, more accurately, photosensitive resin. Each printed layer is built up below the previous layer by using the UV light to cure the resin at the bottom of the tank. Adding layer upon layer in this way eventually builds up a solid 3D object. The two different systems have their own advantages and disadvantages, but, generally speaking, FDM is used for larger objects that need to have physical strength, but not a very high level of detail. SLA, on the other hand, is used for smaller objects that have a high level of detail, but where physical strength is less important. So, let's quantify size, physical strength, and level of detail for each of these two machines. The maximum object size that a 3D printer can produce is dependent upon its own internal space used for printing. Multiplying the length, breadth, and depth of this space will calculate the printer's build volume. For example, this FDM printer has a build space of 22 by 22 by 30 centimeters, giving it a build volume of about 14.5 litres. The SLA printer, on the other hand, has a much smaller build space of 12.9 by 8 by 15 centimeters, which gives it a build volume of about 1.5 litres. In terms of object strength, the FDM printer again wins over the SLA printer. This is because of the material that it uses. PLA filament is a popular and basic choice for FDM printing. It's easy to work with and produces great results. Being made from fermented plant starch, usually derived from corn or sugarcane, it degrades quicker than petroleum-based products and is therefore easier on the environment. And although tough resins are available for SLA printers, most are still considerably weaker than basic PLA. However, where the SLA printer really wins over the FDM printer is in the level of detail that it can produce. Even this basic model is capable of producing extremely fine and intricate features that would be impossible using the FDM printer. Future videos in this series will explain exactly why this is, but, to conclude, let's examine a benchmark, or benchy as they are often referred to, produced on each of these machines. FDM and SLA. Filament. Extrude. Resin. Build volume. Benchy.